this week, and we're going to be going over lesson 16. Any questions or anything we want to discuss before we go into the quiz?
I don't think so. I didn't have anything.
No.
Yeah, it seemed like a really, for me, a blessing, like an easy week.
The homework gets a little weird, but yeah.
Yeah. Okay. Well, let's what's that? Go ahead.
I made my screen big, and now I can't get it to go down.
Oh. I'm going to drop my video so I can actually not get choppy. Okay, is everyone getting the quiz open up?
Yep, I'm ready.
Okay.
I already took it if you guys haven't.
What's that?
I already took it if you guys haven't. Here, I'm going to end the call. 1 sec, I'll be right back.
Okay. Well, you guys have number 1 and 2, right?
It's well, it's a tough one. Weren't you the one that just put like false on a lot of them? A couple quizzes
Yes.
done.
Yeah, thanks for reminding me. That was more for me than for you guys, okay?
Right. You just got to verbalize it. It just helps you keep it straight.
Yeah. Okay, so number 3, I'll just read it. Says, in a pie chart, why are the slices or sectors different sizes? I think number 3.
Yep.
Yeah, long one.
Yes.
Okay. And then number 4, how are bar charts and Pareto charts related?
It's the third one, I believe.
Third one, yeah.
You got that one right? So number, oh yeah, well there's only 3. Okay. All right, number 5. Using the following information for the next 2 questions, we conclude that the sample proportion is normally distributed if the sample and the proportion mean greater than or equal to 10, and the sample is n minus sample or portion greater or equal to 10. So, is P the true portion or the sample portion? Is it the true portion?
The true proportion.
True portion.
Yeah.
Number 6. Sample size.
Yeah, sample size.
Yeah.
Seven. If P is equal to a quarter, what is the smallest n that satisfies the requirement?
I wasn't sure on this one.
So P essentially is 0.25.
Uh-huh.
So it has to be at least 10, greater than or equal to 10. So whatever times 0.25 equals.
It's 40.
40?
40, okay.
Yeah, 40, I think. So 40 times 0.25 is
10.
10, which makes, because it's just a quarter of 40. So if I'm reading it right, I think that's what the answer would be.
I think so.
Yeah, to make it satisfy, yeah, it'd have to be 40.
Okay, so number 8, suppose n equals 24, p equals 4. What is the mean of the sample proportion?
Isn't it 0.4?
Yep.
Yeah, 0.4. That's a trick question.
Right. So it's 0.4.
Yeah.
Answer, did you say?
It's 0.4.
Oh, that's right. What is?
Because that's what P is the
P, yeah.
portion mean. And then number 9, what is the standard deviation of the sample proportion? I plugged that in. I got 0.1.
Yeah.
Where did you plug that into the categorical data analysis
I
sheet?
just made my own.
Yeah.
Oh,
I
you did. I haven't done
I
that
made
yet.
a formula for the standard deviation, and then I just plug in the numbers, and that's what I came up with.
I did that too.
Okay, so that's good. Number 10. Brittany's batting average is 0.3. We want to determine the probability she will get more than 35 hits in her next 100 at-bats. N equals 100, P equals 0.3. What is sample portion of, what is, yeah.
So once again, isn't that just 0.3?
No.
Yeah.
No, because it's not asking the mean. It's
Uh-uh.
asking for the sample portion.
I thought that too, and I got it wrong.
P to P. Okay.
So I think it's
Oh, that
100
okay.
or 30.
My assumption is like in all honesty, I think it's 0.35 because
Yeah.
it's asking.
It's 35 divided by 100.
Yeah.
That's how you get the sample portion. Take the total sample divided by the sample, the how many are in the actual group.
Yeah.
Oh, so 0.35.
Yeah.
Okay. And then if we plug that into your formula, what do we get for standard deviation?
0.046.
Yep. Is that right, Spencer?
Yeah.
Okay, so can all of these numbers here be put into
Yes.
These,
put into this
if you
categorical data?
So
Okay, what are you guys getting for a z-score? Because I don't think mine is right. What I got put in.
what'd you get?
Negative
1.
15.
No.
1.091.
I got 1.07.
It's 1.091 is the answer.
What? Okay, so I guess I'm not understanding how you're supposed to plug this information into the categorical data analysis one. So where do all these numbers go in there?
So
Give me
this one is the z-score is based on the formula in the reading that it's value minus mean. So it's p hat minus p divided by the standard deviation of p hat.
Okay.
That gives you the z-score.
Okay, so you're not using. Go ahead.
Oh yeah, I was gonna say Mike's been watching the videos.
I've been brainwashed.
Okay, so you're not using the spreadsheet that they gave us then.
No, I used the formulas, gave it, and put them into my own spreadsheet.
Yeah.
Got it. Okay.
I couldn't
So
figure out how to use theirs. That's why.
Because what?
I couldn't figure out how to use theirs, or if they were really meant for this.
Yeah. Well, I don't because I'm getting the right standard deviation, but it's not giving me the right z-score. So. Okay. So what was the z-score that you got?
1.091.
Mm-hmm.
And then this one, you have to plug the z-score into the output.
Uh-huh.
Yeah.
And this is the one that always messes me up.
I know. I filled in the center and the left, or I filled in the center and the right, which gave me 0.862. I put that in as my answer and I got it wrong.
I'm thinking it's the other way. Maybe it's 0.138 if you go the other way.
That's what I'm thinking.
You just fill in the 1.
Yeah.
I would think
the far
that
right?
it would. I would think that it's the far right because it says at least 35 hits, which means 35 or more. Correct?
35 or more.
That's correct.
Yeah.
Oh, that makes sense.
Yeah. So
I think-
just
All right,
Right.
yeah, that makes sense. So 0.138.
0.138. Yeah.
Someone plug that in there and see if that comes out right. I don't have the applet open. Is Cody doing okay?
Yep.
Yep.
Okay.
All right, and number 14. So if the true portion of people who support a political candidate is P equals 0.52, and if N equals 2,000 people are surveyed, we want to determine the probability that the results of the survey will suggest the candidate is losing the election, getting less than 50%.
So you use 0.5 for the p hat, right? Because it's 50%.
Yes.
And so if I plug that in, I get, for the standard deviation, 0.011.
Mhm.
I get
Yes.
the same thing.
Okay.
And using this little applet, again, I'm getting a z-score of -44.
No.
We won't go with that answer.
Yeah, I'm just gonna have to create my own spreadsheet for this one because this is a little weird.
I could save this one and send it to you guys if you like.
That would be very helpful.
Yeah, it would be.
Okay, I'll title it lesson 16. I'll send it over while we're talking here.
Okay, awesome. Yeah, it would just be nice to be able to use their spreadsheet because we can actually use that one on the exam.
Yes, this is true. Well, maybe using this, and then maybe we can figure out how to use theirs. Maybe we're just doing something wrong.
Yeah. Because, well, I don't know, because especially on theirs, it's asking for a confidence interval and the type of test, which is, well, and even like their inputs are just weird.
Yeah.
Z-score I got negative 1.79.
Yeah.
Is that right? Is that right there?
Yes.
Okay, so just -1.79. It doesn't go out to 3 decimals.
No, it went out to an even decimal.
It had a 0, but I think that just gets rid of it.
It does. So then, what is the probability the results may show the candidate is losing even though it has 52%? So I initially, I don't know what I got. I don't know why I put the answer I did. But I would assume that the answer is going to be the right or the left. We shade in the left on the applet, right?
Yeah, because it wants to know who's using less.
Where are you going? He's so fast.
So 0.037 then?
Yeah, that's what I have.
Uh-huh.
Okay.
I'll go ahead and submit this.
You say hi to everybody.
Yep. Everything's correct.
Nice.
Awesome. Okay, so I don't know if we want to talk about it while the thing is on. Or if we want to stop the recording. Oh, wow, that sucks.
You missed one?
No. My,
Did you do on your computer?
no, I had opened the quiz earlier today,
Yeah.
and then I went to go submit it again. Okay, hold on, let's see. Sweet. I have to replug in all the answers.
Do you want me to just
But
read
no.
it off to you?
Give me 1 second. So hold on, before we do that,
Gonna stop it?
so do we want to stop it or do we want to talk? I don't think it requires us to talk about it on the thing, does it?
No, I don't think so.
It
All right,
can't
well-
hurt to turn it on, but
Yeah.
Yeah, I would just say
Oh, are
turn
you
it off then.
Are you talking about the project that we got to start doing?
Yes.
Yeah, go ahead and stop the broadcast.
Yeah.